Weeds, insects, and diseases are the three most noxious inhibitors of plant growth in nurseries. They are common to all nurseries and can cause losses in growth and/or plant aesthetic quality, which results in significant economic loss. The negative aspects of these pests can be minimized by an integrated pest control program with a crop production system that is directed toward following optimum cultural practices to produce healthy, vigorous plants. Plants that are properly spaced, correctly pruned, fertilized, and watered are much less prone to pest problems than are plants that are exposed to undesirable environmental conditions. Pest management programs should be designed to monitor and record pest data on a regular basis so that appropriate and timely action can be taken. The goal is not to totally eliminate all pests with preventative pesticide spray programs, but to manage the pest population at a level that will result in minimal pest damage. I'm Dr. DeBusk, and this video defines integrated pest management and goes through the process of IPM for nursery production. According to the EPA, integrated pest management, IPM, is an effective and environmentally sensitive approach to pest management that relies on a combination of common sense practices. It utilizes regular monitoring and record keeping to determine if and when treatments are needed. It employs a combination of physical, mechanical, cultural, and biological tactics to keep pest numbers low enough to prevent intolerable damage. Chemical controls are used only when needed, beginning with the least toxic formulation that is effective against the pest. Education and training play a significant role in making IPM effective, and it has been adopted by a growing number of large nurseries and landscape maintenance operations. The development of an IPM program is in reality the adoption of a new decision-making process for managing nursery pests. The decision-making process is based on an effective monitoring program designed to identify key nursery crops and key pests and to collect the relevant data. Key nursery crops are those most susceptible to pest problems and/or are about to be marketed. Key pests include insects, diseases, and weeds that cause substantial economic loss in nursery production operations. To be effective, monitoring requires keeping good records that include when, where, and what was monitored, recording numbers of pests counted, presence and numbers of beneficial predators, weather conditions, and economic and/or aesthetic impact of the pest. If treatments were applied prior to monitoring, those treatments should be noted and an assessment of their effectiveness recorded. The first decision is to decide if treatment is needed. Is the pest population causing economic losses in growth or appearance? Is the cost of applying a control treatment more or less than the cost of the losses in growth or appearance? What is the customer's tolerance of the aesthetic or growth problems caused by the pest at this point? If it is decided that the plant growth and aesthetic losses are not economically significant, then the next step is to continue periodic monitoring. If significant economic losses apparent are imminent, then the decision is to apply appropriate treatments. The second decision in an IPM program is to determine when and where to apply the treatment. Many biological controls will function only when the pest is at a specific stage of development, for example, laying eggs or larval stage. In some cases, the pest may be coming from an adjacent area. Would it be possible to block the movement of pests from that area to the nursery crop? Would treating the source area be the best response? Will a spot treatment be enough, or must the whole block of plants be treated? Once these questions are answered, it is time to select a treatment strategy. The third decision is to select the most appropriate treatment from a variety of physical, mechanical, biological, or chemical treatments. Growers should use the following criteria in selecting a control treatment: least disruptive to natural controls, least hazardous to human health, least toxic to non-target organisms, most likely to be permanent, easiest to carry out effectively, and most cost-effective in both the long and short run. Most nurseries go through 3 developmental stages in moving from a traditional pesticide application schedule to a fully effective IPM program. Growers move from one stage to the next as they gain more experience and confidence in the effectiveness of an IPM approach to pest management. The first stage involves monitoring of crops to collect insect pest data, because the IPM program for the management of insect pests is more advanced than for other pests. Many nurseries begin with their most common insect pests and focus on their most susceptible crop. Threshold levels of insect populations are then established that cause economically significant aesthetic or plant growth reduction. The tolerance for pest-caused plant damage must be established for each pest and each type of client served by the industry. The first stage requires the investment of more time and effort than will be required once the monitoring process is fully established, and the accumulation of previous records suggests more effective monitoring schedules. In Stage 1, pesticides are only applied when the population reaches the threshold. After the grower becomes comfortable with waiting for economic threshold populations before treatment, he or she is ready to move to Stage 2. Careful monitoring of crops for harmful insects and predators is the first step in integrated pest management. Stage 2 in the development of an IPM program involves the integration of non-chemical treatments into the program. Non-chemical treatments include changes in cultural practices, physical barriers to insects, mechanical devices that trap or limit insect movement, and educational programs. This will result in a reduction or delay in the use of pesticides. The reduction in use of pesticides will slow down the development of resistance in target and non-target insect populations and increases the likelihood that the pesticide will be effective when it must be used. Stage 3 involves making use of natural enemies, including insect predators, parasitoids, and pathogens. The use of natural enemies requires a reduction in the use of pesticides as well as a shift towards using more selective pesticides. Pesticides are used in transition to a system that moves to biological enemies and changes in cultural practices. Pesticides are more frequently used as spot treatments to treat insect outbreaks rather than being broadcast over the entire crop. The IPM program frequently broadens at this stage to include the management of plant diseases, weeds, and vertebrate pests. In conclusion, hopefully you learned more about IPM and the process needed to start an IPM program.